This is lesson 4-7 and 4-7-8 from the Algebra Readiness textbook. For today's lesson, you'll want a sharpened pencil and your notes packet. Begin working on these study guide problems while the video is paused. Continue the video when you're ready to compare your answers to mine. In this first example, you are asked to evaluate and write the expression in simplest form. X divided by y for x equals 6 and y equals 9. When I substitute those numbers into the expression, I get 6/9. I can reduce that by dividing by the greatest common factor, and I get 2/3. The next one, evaluate this one. I know m minus n divided by -12 for m equals -3 and n equals 6. I know that I need to substitute a negative number into the equation or into the expression. When I substitute a negative number, I always use parentheses. Then, following the order of operations, I simplify the numerator first before I would divide. -3 minus 6 is the same as -3 plus -6, which gives me -9 all over -12. Instead of dividing -9 divided by -12, I'm going to leave my answer as a fraction by reducing it and dividing by -3 over -3, and I get 3/4, and leaving my answer as 3/4. Today's learning target is to use the order of operations with exponents. We're going to start by reviewing how to work with exponents. You can simplify expressions by doing as many of the indicated operations as possible. In the first one, I am being asked to take 7 to the second power times 7 to the third power. 7 to the second power is the same as 7 times 7. 7 to the third power is the same as 7 times 7 times 7. So when I multiply this all together, and you will have to do quite a few, because this would be 7 times 7 is 49, times another times 7, times 7, times 7, and you do several side problems before you get the answer of 16,807. I know you can multiply that all out. The next one, we can do the same thing with variables, but remember you can only combine variables that have the same base. A to the fifth is A times A times A times A times A. This is A to the fifth. Then A times one more A. Then times B times B. I can rewrite or rename all of these A's. Instead of A to the fifth times A, I can rewrite that as A to the sixth times B squared. This is as simplified as I can get. I have each base written only one time and then the indicated exponent. All right, let's try this. 2 to the second times 2 to the third. 2 to the second is 2 times 2. 2 to the third is 2 times 2 times 2. Then this really equals 2 to the fifth power. Well, 2 to the fifth power is, some people like to think, I'm going to write that there. Some people like to think of this and chunk it. Like they might know that 2 to the second power is 4, and they might know that 2 to the third power is 8. 4 times 8 gives me 32. Remember, you can group in any order you want because of the associative property. In this one, I can only simplify because I have variables. This is m to the fifth, 1, 2, 3, 4, 5, and then m to the seventh, 1, 2, 3, 4, 5, 6, 7, which is the same as m to the 12th. M to the 12th is as simplified as I can go. I can't give a numerical answer. The next one, I have x to the second times x to the third. Well, x to the second is x times x. X to the third is x times x times x. Then I have y. Y is the same as just one y. Then I have y to the fourth. Written out, I have 5 y's. Simplified, I have x to the fifth and y to the fourth. No, I don't. I have y to the fifth, don't I? So this is how we simplify our variables. Let's try some of these. Pause the video, try these, and come on back to compare your answers to mine. All right, in the first one, in doing your multiplication, you should have had 0.3 times 0.3 times 0.3 times 0.3 times 0.3. Oops, do I have one too many? I do. Let's try this again. Here we go. So this is 3/10 to the third, and this is 3/10, just the 3/10. Now, you multiply as though the decimals aren't there, which is 3 times 3 times 3 times 3, and I get 81. Then I have 1, 2, 3, 4 places after the decimal. So 1, 2, 3, 4. And I get 0.0081. The next one, I have 2/10 times 2/10. That's what this means. And then the next one I have is 2/10 to the third power. So I'm going to write 3 2/10. So when I multiply this, remember how to multiply decimals. Multiply like the decimal isn't there. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Then I have to count up the number of places or digits after the decimal. 5. 1, 2, 3, 4, 5. And fill in with zeros. My answer is 0.00032. Letter C. 3 to the second power is 9. 3 times 3. A star means multiply. And then I have 2/10 to the third power, which is 2 times 2 times 2, which gives me 8. And then move the decimal. Let me write this down here in case some of you had a hard time with that. So 2/10 to the third power looks like this. Now you multiply the decimals or multiply the digits as if the decimal isn't there, and I get 8. Then I see that there are 3 places after the decimal point, and that's how many places I move the decimal in the answer. That's how I got 0.008. Then I multiply it by 3. Now, I'm going to shuffle this around a little bit. 9 times 3 is 27. 27 times 0.008. I'm going to do a side problem over here. 27 times 8. 8 times 7 is 56. 8 times 2 is 16. Plus 5 is 21. Then I see that there are 3 places, really. 1, 2, 3. And my answer is, let's see if I can write it, 216 thousandths. So you have to use your decimal rules. You've got to use your multiplying or exponent rules, all coming into play here. Then this one, 4/10 times 4/10 is the same as 4/10 to the second power. Remember to multiply these as if the decimals aren't there. 4 times 4 is 16. Then how many digits are there after the decimal? 2. So 1, 2. The decimal goes right there. So 16 hundredths plus 27. I solved the exponent before I started adding. Now, some of you are going to get this confused. Where is the decimal in this 27? It's at the end. So when you're adding these two numbers, 1600ths plus 27, you need to line up those decimals. Do not just stack the numbers. Your answer is 27 and 1600ths. All right, what if I have coefficients? That's no different. Let's give these a try. I'm going to do the first one, then I'd like you to try the next two. Do you see that this really means the same thing as 6 times a to the third times 3 times a? Well, I can use the commutative property that allows me to change the order of my numbers. Now, do you have to write that step? No. If you remember, I'm going to multiply the coefficients together and get 18. And then I'm going to multiply a to the third and get a to the fourth. That is totally fine. But it's good to know why that works. And the reason it works is because I can rearrange the numbers and then use the associative property to group those. And I get 6 times 3 is 18. A to the third times a is 4 a's, so a to the fourth. Pause the video and try the next two. Come on back when you're ready to compare your answer to mine. Hopefully, you multiplied -5 times -3 and got +15. Then you wrote out 2 C's and 7 C's, and you got C to the 9th. For letter C, 4 times 3 is 12, and you wrote out 2 X's and 4 X's and renamed it as X to the 6th. Division with exponents is much the same. We're going to write out our exponents in expanded form. I have 5 to the third, 5 times 5 times 5 in the numerator. And I have 5 to the 6th in my denominator. Now, what is 5 divided by 5? 1. 5 divided by 5 is 1. 5 divided by 5 again is 1. So really I have 1 times 1 times 1, or just 1 in my numerator. And in my denominator, 1 times 1 times 1 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. All right, let's try the next one. Writing this out in expanded form, I've got 3 2/10 written 7 times. There we go. And then I've got 3 2/10 written That's not what I wanted to do. 3 2/10 written 5 times. Now, what do you suppose happens if you have 3 2/10 divided by 3 2/10? It cancels out, doesn't it? It equals 1. And then another one cancels out and equals 1, and another one, and another one, and another one. What I'm left with is 3 2/10 times 3 2/10, which gives me, you'll have to do a side problem, doing 32 times 32. Let's write this over here. 32 times 32. And you get 4, 6, bring the 0 down. 3 times 2 is 6, 9, and I get 1, 0, 2, 4. Now, in the original problem, there were 2 decimal places, so my answer is 10 24 hundredths. Now, you're not always going to see your exponent written as an exponent. Take a look over here on the right. Do you see this problem? That little rooftop, that is called a caret. It looks like the top of an arrow, and it is used to indicate the number, that the number following it is an exponent. So this means 3 times 2.25 to the second power, like this. But writing it with a little caret is another way you might see it. So make sure you're okay with that. In this problem, we're being asked to substitute 5 in for x and solve using the order of operations. Make sure that you're aware that you need to follow the order of operations inside your grouping symbol. The first thing we need to do, parentheses, exponent, multiply or divide, add or subtract. Here we go. First, we're going to do our grouping symbol. Inside of our grouping symbol, I'm going to multiply first. And I get 10 minus 5. Now, it would almost seem like I should do exponents next, but I can't because my parentheses are still grouping 10 minus 5. 10 minus 5 is 5. Now, don't take 1/3 times 5 yet. I only finished my parentheses or my grouping. Now I need to do the exponent, where I take 5 to the second power. 5 times 5 is 25. Now I need to take 1/3 times 25. 1/3 times 25 is the same as 25 over 1. So I really get, remember how to multiply fractions? 1 times 25 is 25. 3 times 1 is 3. I need to take 25 divided by 3. 3 does not go into 2. 3 goes into 25 8 times, and I get 24. When I subtract, I get 1. I bring down the 0. 3 goes into 10 3 times, and I get 1 again. I get 8 3/10 repeating. Okay, let's look at the next one. In the next one, I need to take and do my parentheses first, but there is nothing being grouped. The next thing I need to do is my exponent. So I need to take 2.25 to the second power. So you're going to take 225 times 225, and then you're going to get a really long decimal. That's yuck. And you're going to get 5.0625 times 3. Now, you're going to take that, times it by 3, and you get 15.1875. This one is just to demonstrate for you how to do it. We'll do the math on some of the other ones that aren't as difficult of a problem or not as time consuming. All right, I would like you to pause the video and try these two. When you see, and then come on back to compare your answer to mine. These might make you struggle just a little bit, but don't be afraid. We're going to go over it together. All right, for the first one, I'm going to rewrite the problem. Remember that this means that that is an exponent too. So make sure you write that in your notes if you've forgotten. Now, we're going to solve this using the order of operations almost like it's a to-do list. Okay, so I'm going to actually make it look like a to-do list by putting little boxes in front of it. We're going to check off the boxes. First, let's simplify any grouping. Well, I see right here I have some grouping. 8 minus 2 times -4 plus 4 is 0 times -3 to the second power. None of the other parentheses are grouping. The next thing I need to do is exponents. That's right here. And everything else I just write as is. This means -3 times -3. -3 times -3 is a positive 9. There are no more exponents. I'm done with that step. Next, do not take 8 minus 2. Next, you need to multiply or divide from left to right. So I need to take 8 minus 2 times 0, which is 0. Then I need to finish multiplying. 8 minus 0 times 9, which is 0. Now I'm done multiplying. 8, now I add or subtract. 8 minus 0 is 8. Okay? Using that same step again, we're going to solve the next problem. This one might throw you off. This means 1/4 to the second power times 1/4. 1/4 to the second power means 1/4 times 1/4 times 1/4 again. How do you multiply fractions? Do I need a common denominator? No. You multiply all of the numerators. 1 times 1 times 1 is 1. 4 times 4 is 16. 16 times 4 gives me 64. 1/64 is my answer. Now, I want you to write a little note. There's a question like this on your test. Make sure you know how to do this problem. Now, just a reminder, 0 as an exponent. Any number raised to the 0 power is 0. 43 to the 0 power, I'm sorry, did I just say 0? Any number raised to the 0 power is 1. So if I have 1/5 times 2 to the 0 power, it's 1/5 times 1, which is 1/5. 4 to the second is 16 times 4 to the 0 power, which is 1, gives me 16. All right, let's try these last two. By pausing the video and coming on back, then compare your answers to mine. 3 to the third power is 27. 1/2 to the second power is 1/2 times 1/2. So 27 plus 1/4. 1 times 1 is 1. 2 times 2 is 4. 27 plus 1/4 is 27 1/4. The next one, this is the same thing. 3 with caret 3 is the same as 3 to the third power. Just like this one. This means the same thing. Minus 7, 5 times 5 minus 3. Before I evaluate that parentheses, I need to evaluate the parentheses before the exponent. 3 to the third minus 7 times 5 minus 3 is 2. 3 to the third is 27 minus 7 times 2. The next step is to do my multiplication or division. Do not take 27 minus 7 first. I know that's tempting. I have to do multiplying first. 27 minus 14. 27 minus 14 is 13. So here's your study guide problems. This is how it's going to show up on your quiz. Your chapter test. We will have this is the last lesson in chapter 4 before your test. So make sure you're able to solve all of these 4 examples so you're ready for your test. Pause the video, try all of them, then come on back to compare your answer to mine. For the first one, 8 to the third times 8. This means 8 times 8 times 8 times 8. Because this is 8 to the third, and this is that last 8. Then once I have all those 8s written out in a string, I always get kids who say, well, can I just take 64 times 64? And the answer is yeah, absolutely. And when you do that, you get 4,096. The next one, 4c to the fourth times negative 8c to the fifth. Remember, you multiply the coefficients first, and you get negative 32. Then you have c times c times c times c for c to the fourth, and c times c times c times c times c for c to the fifth. How many c's are there? That's c to the 9th. So negative 32, c to the 9th. The next one, there are 7 a's in the numerator, and there are 5 a's in the denominator. Then when I divide, they equal 1 or cancel out. What's remaining is just 2 a's, or a times a is a to the 2nd power. The same thing is true when you're working with numbers. I have 2 to the 4th, which is 2 times 2 times 2 times 2, and then variables, which is 6 m's. Then I've got 2, and then I've got 5 m's. 1, 2, 3, 4. Then I can work on what cancels out. 2 divided by 2 is 1. M divided by m is 1. Another m divided by m divided by m divided by n, m. What's remaining is 2 times 2 times 2, which is 8. And then I have 1 m remaining. Your assignment is the 4-8 worksheet that is found in your notes packet. Give that a try, and then